Okay. Let's start this class. Yeah, today we will talk about continuous time convolution integral. Do you remember what we talked about last class?
Just different, I mean,
Yeah, that's right. We talk about that. But we mainly focus on the discrete time convolution, like sum. Yeah, but today we will talk about the continuous time convolution integral. Yeah. And those properties we use it to simplify our computation. Yeah. And then this is our today's goal. Firstly, we will review the convolution sum for dt, like a discrete time LIT systems. Actually, we talk about the convolution sum, but we haven't finished it. There are some examples we haven't finished. Yeah. And then we try to compute the convolution integral for CT LIT system analytically and graphically. Actually, if we are familiar with the convolution sum for DT, the convolution integral CT, actually it's a similar idea. Yeah, just a different calculation form like that. Okay, let's try to review the DT LIT system. And let's start from the beginning. And what's the result for this equation? X0, am I right? Yeah, that's right. Yeah, here we use the sampling property. Yeah, and then it will equal x0 delta n. Yeah, which means when n equal 0, it is 1. Otherwise it is 0. And we use these sampling properties, we can get what's the result for this one? Huh? Actually, yeah, what is delta? Delta n minus n naught. Where is it? What is delta n minus n naught? Yeah, what is this? Just remember when this part equal what? 0, and the value will be 1. Am I right? Which means n equal n naught, it will be 1. Otherwise, it will be 0, right? And one item or multiple 0, it will be 0. Only when n equal n naught, am I right? So what's the value? What's the result for this one? Which means n equal n naught, it has value. Otherwise, it will 0. Yeah, x n naught and multiple this item. Yeah, actually, we also call this, it's kind of like a shift property thing, like that. And then from this one, we just get this equation. The xn equal like x key multiple this one, like from negative infinity to the positive infinity. Actually, we prove it in the last week class. Yeah, the first class for the chapter 2. If you want to know why this equation works, you need to recheck that. But any question for this equation? Yeah, we prove like why this. Okay, and then we use this we call the DT safety property, and then we like mention a very important like a content. What's the name for delta n? What's the name? Impulse function, am I right? So what is Hn? Yeah, impulse response. Yeah, actually the Hn is just the delta n goes through one system and the result, am I right? The output like that. Yeah, so we call it impulse response. Actually, this one is very important for the chapter 2 and chapter 3, 4, like that. And then for this one, for this impulse response and the LIT system, we can get this equation. Yn equal xk multiple hn and add them together. And we also improve, like we also prove why this equation works. You can check that, check the next week's class. And what's this equation? Do you know? What's this equation? It's just convolution. Yeah, it's just convolution. So what is a convolution? What is convolution? Let us talk about one more time. It's just an operation, like multiple, like a divide, like a plus, like a minus. The convolution is just one operation. And the meaning of that operation is multiple two function together and add them together, multiple atom and add them together. Does it make sense to you? Yeah, this is a convolution. And we can use what symbol to represent a convolution? Yes, the star. Yeah, this one. Am I right? So here, the yn can equal xn convolution with hn and equal hn convolution with xn. Actually, what property we use here? Yeah, commutative. Yeah, the order can be changed. And then we call this convolution sum. Yeah, and yeah, this is why we have already proved why we from here to here. Yeah, you can check the last week's class. Okay, and then from this equation, we can have this equation. If you're like hn equal this one, and then your output should equal this one. We call this, what's the name for this property? Yeah, shifting property. Actually, the shifting property is very important. You can see when you try to resolve many problems for the convolution sum, the shifting properties you always use. Yeah, we have already talked about some examples. Okay, then let's talk about the analytical convolution sum. Actually, we talk about some examples, and for the analytical convolution sum. Yeah, there can be computed in two cases. The case one, the xn and the hn are given as short impulse sequences, and then we can use some properties, the shifting property, distributive properties, to simplify your computation a process. Yeah, we have already talked about some examples. Yeah, any questions for the case one and case two? When the xn and hn are defined with a closed form, the key is to convert the convolution sum into the geometric series sum as two different. The one is like your form will be write as this form, and then you will use geometric series equation for this. And for the this one, actually you can see the difference between this one and this one. Do you notice? Do you notice the difference between this one and this one? Why we just try to divide two different situations? You can see this situation, your n should from n naught to positive infinity, but here it is from n naught to n1, which means it has a duration, the specific duration. That makes sense to you? Yeah. So if you try to find the result for the case two, and you need to pay attention to this situation, those two situations. And for this one, you can see this one, this equation equals this one. That makes sense to you? Any questions so far? Why? Do you know why this equation equals this equation? You know why?
It's just creating where it's still giving you movement, like you can only go from 0 to the end +1.
Yeah, you can see this one is just n naught to positive infinity, right? This one is n naught n1 plus 1 to positive infinity, which means this one. Let me write it down. It will be easier for you to understand. You can see n naught infinity, like a n. Actually, this one equal n1 a n plus n equal n1 plus 1. That makes sense to you?
Yeah.
Am I right? So which means if you use this equation, minus this part, Then you get this part. Am I right? So that's the reason why this equation works. Any question so far? Okay, and then after this, and you also from here you can see this is the one equation you can use, and here also you can use that equation, but just the a lower boundary is different. That makes sense to you? Yeah, and then you can get this result. Yeah, actually, this set is very important. Yeah, and it will help you to deal with the analytical convolution sum. Yeah, actually, we talk about some examples, and before, and in last class there are two examples we haven't finished. Let's check that too. And the first one is okay, this one. You can see this is our input and input signal. Sorry, and this is our input response. What's your output? What's your output? Yeah. Huh? Just remember this. Yeah, convolution with HN, am I right? Yeah, just remember that. And also, you can see if your xn and hn is just a simple impulse response thing, and you can use just use some properties. But if your your input and impulse response is not that easier, is not that simple, and you need to use this equation. Yeah, this equation is also like convolution equation. Yeah, and then from here, we just put x k here and hn minus k using this equation, because you can see this part is just xk. Am I right? You just replace n with k. Am I right? And for here, you just replace n with n minus k. Am I right? Yeah. And then this equation equals this equation, y. Actually, I talked about this in last class. Y. Why this equation equals this equation? Because you can see, huh? Yeah, you can see one atom disappear. Am I right? This, what is UP minus 2? What is UP minus 2? What is UP minus 2? What's this function looks like? Oh, what's the name for this function? Firstly, unit step function. Am I right? So what's this function looks like? We talk about only when this value greater equal 0, it will be 1. Am I right? 1. Otherwise, it will be 0. Am I right? So which means if p greater equal 2, it will be 1. 1, 2. This is p. It's just looks like this, am I right? So which means that when my k greater equal 2, and that atom will be 1. And I just like 1, you don't need to put it here, am I right? And otherwise it will be 0. So which means I just remove smaller than 2, am I right? Yeah, so we can get this equation. And for this equation, we also don't want this atom, am I right? So this atom is also a unit step function, am I right? So we try to talk about this one. And if we want to remove this one, which means we just want to find this equation, we make this equation works, and then this atom will equal 1. That makes sense to you? Yeah. So then we can get k smaller equal n plus 2. Then we can remove this one. Am I right? So here we know k should greater equal 2. Am I right? And smaller than n plus 2. That makes sense to you? Yeah, from this atom, we know like the k should greater equal than 2. And from this equation, we know k should smaller equal than n plus 2. Am I right? So we can, which means this is an upper bound. That makes sense to you? Yeah, and then our equation can become this one. K should greater than 2, greater equal than 2, and smaller equal than n plus 2. Am I right? And then we can remove this atom. If k like greater than n plus 2, which means it will like 0, we can remove that. That makes sense to you? Yeah, so then, which means n plus 2 must greater equal than 2, am I right? Otherwise, it will not work. That makes sense to you? That makes sense to you? Any questions? Which means n must greater than 0. That makes sense to you? Any questions so far? Okay, and then we let m equal k minus 2, which means we can like change, we can transfer our equation here. Yeah, because if m equal k minus 2, which means m can start from 0 to n. That makes sense to you? And then here, this is k minus 2, am I right? It is m, am I right? So then the equation will become easier, because you can see it is just this equation. Just this equation. That makes sense to you? Yeah, so you can use this equation. What is a here? What is a here? You use one. You want to use this equation. What is a here? Half. Am I right? What is n1? What is like n now? N now is what? 0. Am I right? What is n like n1? N1 is n. Yeah, that's right. So you just put n1 like n now and a into this equation. Am I right? And then, yeah, actually, yeah, I just put this equation here. Am I right? That would be easier. And then you can get this equation. Yeah, just put like n now equals 0. So this one will become 1, and this will be a n plus 1, and this is 1 minus half. That makes sense to you? Any questions so far? Okay, and then this equation can become this one. Any question? Yeah, because 1 over half is half. This part is half. Am I right? So you just multiple to here to this equation, multiple 2 to this equation, and then you can get this equation. Any questions so far? Okay, and then n must be greater than 0, greater and equal 0. This is the condition. Otherwise, and your equation will not work. That makes sense to you, because we talk about that here. Any questions so far? Okay, yeah, and this is so yn should equal what? This is your output. Why this equation become this equation? Why is it here become here? Do you know why? Why we add un here? What is un? What is un? Yeah, 1. When n greater equal 0, it will be 1. Otherwise, it will be 0. You can see here, we have this condition. Am I right? So for now, for this equation, we don't have that condition, because the un is just the same with that condition. That makes sense to you? Yeah. Any questions so far? Any question? Okay, let's talk about the other example. This is our signals, and this is what's the name for this one? Hn, what's the name? Yeah, just remember the impulse response. And then what this is just if you try to draw it, it is just like that. And what is yn? Yeah, convolution. This equation, am I right? And then we put xn Yeah, xk. Yeah, because we need to use k to replace n, am I right? So this is sk, and we need to use n minus k replace n in this equation. So we get this sk and hn minus k, am I right? Yeah, and then we can have this equation. Any questions so far? Okay, then what should we do? Follow the previous example. What's the next step? What's the next step? Actually, we don't like a u function, am I right? We want to remove it. Just remember, if you want to calculate the convolution sum, just try to if xn hn is just like a short input sequence, you can use some properties to simplify that. If it is not, you need to use some method to make your form looks like this type and this form and this form, and then use this equation. That makes sense to you. So for this equation, we don't like the u function, am I right? We want to remove it, am I right? So then let's check the first one. For the first one, how can we remove it? uk minus 4, how can we remove it? Similar idea. Yeah, I think you're right. Which means only p minus 4 greater or equal 0, it will be 1, am I right? Otherwise it will be 0, am I right? So which means k greater or equal than 4. And then you can remove it, am I right? So yeah, this is xk, this is hn minus k. Yeah, you know that, am I right? So which means if k greater equal 4, and we can remove this part, uk minus 4, am I right? And then let's check about this one, this part. How about this part? How can we remove this part? The similar thing, am I right? Which means we need to let 2 minus n plus k greater equal 0, and then we can remove this one. That makes sense to you? And then let's talk about k should greater equal n minus 2. Am I right? And but from this atom, we know like k should greater equal than 4. Am I right? And then here we also have the other lower boundary. K also should greater equal than n minus 2. Am I right? So which means it is a new lower boundary. That makes sense to you? So there are two different lower boundaries. Am I right? So we need to talk about which one should be the lowest boundary. Yeah, you can see if your n minus 2 smaller than 4, which means your k, your minimum k should be what? If you want to remove this atom and this atom, if this situation, if your n minus 2 small, yeah, you're right. The minimum should 4, because you can see the n minus 2. If it is if your lower boundary is n minus 2, which means your k matter smaller than 4, am I right? So this atom should not be removed. That makes sense to you? Any questions so far? Okay. Any question? Okay, and then the other situation, if n minus 2 greater than 4, which means which value should your k minimum value? If for this situation, we know like the key minimum value is 4, am I right? And for this situation, what is your key minimum value? n minus 2. Yeah, you're right. So which means, but let's just talk about two different situations. Yeah, and for this situation, and we know like the key minimum value will be 4, and the upper value will not be changed. Am I right? Because we just talk about the like a lower boundary, and then we just put yeah, because this is just around like a key, and we put the 4 power n output out this sum, and then we get this one, and then we have this one. Am I right? Yeah, it's just like a 4 power negative k is equal 1/4 power k. Am I right? Yeah, this is just like a fundamental mathematical thing. Am I right? Yeah, and then we have this equation. Yeah, am I right? And from this equation, you can see we have this form. That makes sense to you? We have this form. Yeah, because it is a positive infinite. That makes sense to you? Yeah, so we just use this equation. Am I right? And then you get this equation. And finally, you get this one. If you calculate it. Yeah. Any questions so far? Okay, and then for this situation, we know the minimum value should be n minus 2, am I right? So your equation should become this one. And then a similar thing, but just the boundary, the like lower boundary is different. And the similar thing, and then you use this one, and you use this equation. But for this equation, and the key is just like start from n minus 2, am I right? And here is n minus 2, like that. It's not like 4, am I right? Yeah, other things are same. Yeah, so your final results will be like this. Any questions so far? So what does that mean? Which means if you have if you have a lower boundary, you have a upper boundary. That's good. Am I right? Just one lower boundary and one upper boundary. That's totally fine. Am I right? You can use this equation to get calculate. Am I right? And for this situation, you have 2 different lower boundary. Am I right? Yeah. So you need to talk about which one is like a minimum lower boundary. Am I right? Yeah, so this is one situation. This is the other situation. You need to talk about that. What does that mean? Which means your output should equal different, like should have different equation. Depends on your n value. That makes sense to you? If your n smaller than smaller equal than 6, and this is your output. If your n greater than 6, this is your output. Any question? Any question? Okay, so let's talk about the other one. This is our xn, this is hn, and what is yn? Yeah, convolution. Just remember the convolution. This is your convolution equation, am I right? So, and we know like the key, the x key is just from 1 to 4, am I right? Other like is just 0, am I right? So our key is just from 0 to 4. That makes sense to you? Any questions so far? Yeah, because you can see our xn is just like from 0 to 4, it has value. Other like other n value, there is no like, it's just 0. That makes sense to you? So we can just write the equation from this to here. Any question? Okay, and then like when x equal 0 to 4, the x key equal what? 1, am I right? So which means you can remove x key, am I right? So you have this equation. That makes sense to you? So which means your xn equal what? This one. Yeah, when k equals 0, it is hn. When k equal 1, it is hn minus 1 plus n minus 2 plus n minus 3 plus n minus 4. Am I right? That makes sense to you? Yeah, and then this is your hn. Am I right? What is hn minus 1? You have hn. What is hn minus 1? hn is this whole figure. So what? Yeah, this is hn. What is hn minus 1? Shift. Am I right? Shift to right. 1 unit. Am I right? So then you have hn minus 1 like this. Yeah, because shift to right 1 unit. Am I right? Any questions so far? Yeah, after you shift, actually, your signal will become this one. Yeah, because you can see you shift, this is 1 plus 1, because you plus. So your value here is 2. That makes sense to you? Yeah, does it make sense to you? Yeah. Then what is Hn minus 2? Shift. Yeah, shift to 2 unit. And then your and the plus together, you get this one. Am I right? That makes sense to you? And then H minus 3, similar. You shift and plus. Am I right? And H minus 4, you shift and plus. And then this is your Yn. That makes sense to you? Any questions so far? Okay, and then let's talk about the other question. Actually, this is a homework. Yeah, this is our xn is this our signal is here this situation, and our impulse response is this one, and then here we know the n smaller equal than 0 than that, and determine the value of n given that Yn equal Xn convolution with Hn, and yeah, there are some conditions. Y4 equal 5 and Y40 equal 0, and then which means which we know the n smaller than equal none. For this equation, for this question, we need to determine the value of n, specific value for n. So what should we do? Actually, firstly, let's try to write down the output first, am I right? Yeah, because we know the xn and hn. What is yn? What is yn? What is yn? Convolution. Yeah, just remember that. Yeah, convolution, am I right? You know this equation. And then we know the xn, if xn equal greater than 0 and smaller equal than none, it is 1. Otherwise, it will be 0. So we can transfer our equation right like this. Why? Why? You know why? From here to here, from here to here. Why? Huh? Yeah, I simplified, but why? Yeah, you can see, this is xn, am I right? This is our xn, which means n during 0 to 9, it will be 1. Otherwise, it will be 0. Am I right? So which means why we remove x key here? Because when k equal 0 to 9, the x key 1. Am I right? That's the reason. That makes sense to you? Okay, and then let's continue to talk about that. Yeah, so we know the x4 equal what? X4 equal when n equal 4. This one, am I right? So this is x4, and if we just expand it, it is when k equal 0, it is h4, and when k equal 1, it will be h4. When k equal 3, when k equal 2, it is 2. When k equal 1, it is 1. 3, it is 1. When k equal 4, it is 0. Am I right? It cannot be because if it is smaller than n, if this atom smaller than 0, it will be 0. So we don't need to write it down here. Am I right? So which means this is 5. Does it make sense to you? Yeah, so this is, we have already got. And which means the n greater equal 4. Am I right? That makes sense to you? Does this make sense to you? Because you can see the n at least greater equal than 4. Am I right? Am I right? Yeah, and then for the 40, and we have the similar equations, and we have this. We will have this equation, and it will equal what? It will equal 0, am I right? So which means the n should smaller than, well, because all those equations, all these items equal 0, am I right? Which means this n should smaller than 5. That makes sense to you? If n greater equal than 4 and smaller than 5, what's the value for n? Huh? Yeah, if n smaller than 5 and greater equal than 4, what's the value for n? I think this one is easier, right? If n greater equal than 4 and smaller than 5, what is this number? What is this number? Huh? Huh? What is this number?
Well, we're saying it is wrong.
You see it? See it? Huh? Let me, yeah, if I write it here, if we, a number, integer number, greater equal than 4 and smaller than 5, and this number should be the integer positive number. What's the value for this one? It cannot be point, like 4.5. No. What's the value? I think this one is easier, right? Huh? Huh? Question? What's the value for n? Huh?
4,
Huh? It should be smaller than 5.
yeah,
So it cannot be 5, right?
yeah, so anything in between.
4 or 5, between 4 and 5, right? But it must be an integer. You can see it cannot equal 5, but it can equal 5 or 4.
So
It must be 4, right? Yeah. It must be 4. Am I right? Yeah. So do you know why? Yeah. Since this is our equation for the yn, am I right? So y4 equal this one and equal this one. And we know the question give us it is equal 5, which means 0 each 0 must be equal 1. H1 must equal 1. 5, 4, 5, 3, 4 must be equal 1, am I right? Which means here the n here must greater and equal 4, am I right? And for this equation, yeah, y40, we use the similar equation and get this atom, but it equals 0, which means all these atoms will be 0, am I right? So which means the n must be smaller than 5 because H5 is 0, right? So then we get the n must be 4. That makes sense to you? Yeah, this is the homework. Okay. Yeah, n equal 4. Any question? Yeah. Okay. Then let's talk about the CT-LIT system. Actually, the CT-LIT system is very similar with DT. Okay, what's the result for this one? Yeah, x0 delta t, am I right? And we call it a sampling property. And then we get this one. What's the result for this one? Yeah, xt now. Delta, yeah, it's a similar thing. Not just like replace n with t, am I right? Yeah, but it's all t. But one is just like the integer number, and the other is a continuous number. Yeah, and then we have this one to get this equation. Yeah. Do you remember the difference between this one and this one? Yeah, one is summation, and one is integral. Yeah, because one is like a discrete, one is continuous. Am I right? So that's the reason why here is this symbol. Okay, and then this is CT shifty property. And what's the name for delta t? Ask you again.
Period.
Huh? period. Impulse function, but this is CT impulse function. Yeah. What is the name for HT? Impulse response. Yeah, just remember that. Okay, and then from since this is the LIT system, and then we have this equation. What's this? What's this? What's this? Convolution. Yeah, it's still convolution, but it's convolution integral. Yeah, so we also can use star to represent it. Yeah, and then what's the property for this one? What's the property we use here? Commutative. The order can change. Yeah, and we call it, we name it convolution integral because they just use integral. And for the dt, it's called convolution sum. And for the ct, it is called convolution integral. Yeah, any question so far? Yeah, actually it's very similar. And then we have this, yeah, we have this property. This is shifting property. Yeah, it's similar with dt. Any questions so far? Okay, and then let's try to sum the convolution integral. For the convolution integral, this is integral, can be computed analytically according to the following two cases. The first one, yeah, still full. The first one is ST or HT are given as impulse sequences, like similar like this. And then you can use some properties, shifting property and distributive property, communicative property, and yeah, some properties to simplify your answer. Yeah, and get the result. And for the case 2, like when ST or HT are given in terms of this equation, like exponential equation multiple, what's the name for this one? Unit step function, am I right? If you're like a ST or HT are giving you this term in terms of this one, and then you just try to like transfer your like output in this form and using this equation. Yeah, this is the convolution integral. Yeah, you can see. Let's try to compare. This is a convolution sum. You can see very similar. Yeah, but just like one is discrete and the other is like a continuously. Am I right? Am I right? Yeah, any questions so far? Okay, let's talk about some examples. Yeah, the key is to remove the unit step function by changing the boundaries of integration to make the integration computable. Yeah, actually, the idea is very similar. Yeah. Okay, let's try to review example 1. And this is our what's the name for this? What's the name? HT. What's the name for HT? Yeah, impulse response. And then this is our impulse response, and this is our signal, input signal. And okay, let's talk about the HT convolution with IT. What will be the result? Case 1 or case 2? Huh? Huh? Yeah, sorry. Case 1 or case 2? Actually, I think it is case 1, right? Yeah, because it's just given a impulse sequences, am I right? So you can use some like property. What property you can use here? What are properties? What are properties? I think this one is easy, am I right? Yeah, distributive. And then shifting property, am I right? Yeah, you can get this one, am I right? So this is your output, which means your output should be this one. Shift T now, shift right to shift right T now and shift left T now. Am I right? Yeah, and then, but yeah, this is your output. But we don't like overlap. Am I right? We don't like the output overlap. So we need a guarantee there is no overlap. So which means the T t now minus 1, this point should greater than this, greater or equal to this point. Am I right? That makes sense to you? So this point is t now minus 1. And this point is t now, negative t now plus 1. Am I right? So which means we just make sure this equation works. Am I right? Then we have this t now should greater or equal 1. That makes sense to you? Yeah. And this is the other, like the other example. Yeah. And without loop and yeah. And we will talk about more examples for like a CT situation, like a CT, like a convolution integral. Yeah, in next class. Any questions so far? Okay, we will now have new like homework this class, and I will give you the new class new homework next class. Okay, is that okay? Okay.